Hello everybody and welcome to Extreme DX. I'm your host Bruce. In today's episode we're going to continue reverse engineering the McKay Dymec DA-9 active antenna, and we're going to concentrate on the head this time. And I've got several different ferrite bar configurations that I'm going to test, and we're going to see which one gives you the most gain. And of course, some of this has to be tempered by the materials you have at hand, how many ferrite bars you've got, what size and shape they are, what type of wire you have. But I'm going to try to keep as many variables as possible constant. Getting started, I have a 200 millimeter by 6 millimeter ferrite bar in this little plastic box. Now, for the tuning capacitor, I'm just going to use these that I ordered off of eBay. And I have this preamplifier board that I cloned from the DA-9. So I'm going to use the same capacitor and the same board for all of these. And I'm only going to use one station this time. This is the one from San Antonio that I use sometimes. And I am seeing a 67 to 68 on the meter. Okay, I've got the 200 millimeter by 8 millimeter ferrite bar, and I'm seeing 62 to 63 on the signal strength meter. With the 200 millimeter by 10 millimeter ferrite bar, I have seen as much as 71 or 72 on the meter. Okay, this is where I'm starting to group together ferrite bars. I've got 3 of these 200 millimeter by 8 millimeter ferrite bars taped together, and I am seeing a big jump on the signal strength meter. I have an 82. Next, we're doing 7 of these 200 millimeter by 8 millimeter ferrite bars. On the signal strength meter, I have 87.6. Okay, let's take this to an extreme. This is a Stormwise monster ferrite bar. I have no idea what's inside of the pipe. I only know that they are marketing this to the AM/DXer market. But let's see what it's actually doing to the signal strength. And I have a 68. And finally, let's look at the original itself. Now, I took the measurements of 30.5 millimeters and 19 millimeters, but it's really 1 foot by 3/4 inch ferrite bar inside the head. So this ought to be really good, right? Well, I've got a 61 or 62 on there. But one thing I will mention now, and that is, this is the clearest audio I've gotten on this station today. That's because you have aluminum on 3 sides of this head. So if you can go to Home Depot and get some aluminum pieces to electrostatically shield your antenna, you're going to be much better off from the standpoint of electrostatic noise. Combine that with a super ferrite and you'll have a very good ferrite bar antenna. And here's the whole set of test ferrite bar antennas. Let's take a little look at the specifications on them. The 200 millimeter by 6 millimeter, I've got the ohms and resistance first, and then the inductance in, I believe that's millihenries. Yeah, it's millihenries. So 0.21 millihenries, 210 microhenries. Then you go down the column, you do the 200 millimeter by 8 millimeter, you've got 0.5 ohms, 0.17. You've got the 10, it's 0.5 ohms, 0.17. Then the 3 bars together and so forth. We already know that the original head is 0.5 ohms and 190 microhenries. So it gives you an idea of what you should shoot for when you're winding the wire. I use multi-stranded wire that I have a big reel of, so I wasn't really trying to use Litz wire or anything with really low impedance, because that's really hard to work with. I do have some good news on these 200 millimeter by 8 millimeter ferrite bars that I've used in single, triple, and 7 configuration. You can buy these Ferrite bars on Amazon. They're not cheap. I think 2 of them were like $15, but you can get them through Amazon. And with that and being able to wind the wire yourself, you should be able to make one of these heads. And here are 3 head units that I made. I used some emblem style automotive sticky tape to stick the Ferrite bars in there, but I may fill up the interior of these with styrofoam in order to keep the antennas in place. I put them to one side so that you can put them on a tabletop that's metal without a whole lot of conduction between the antenna and the table, although you probably need more height than that. I'm using discrete wires instead of coax because the coax has parasitic capacitance in it, and you don't want that to detune your unit too much, otherwise you won't be able to make it to the high end of the band. And then finally, I have this little switch unit. Why, you ask? Well, I burned out several FETs soldering and unsoldering antennas to them, so I have this switch to short out the antenna while I change heads, or for storage when I don't have a head attached. And that's it for this week. We're talking about the heads this week, and I'll tell you about the little amplifier box next time. If you like the content, click on the subscribe and hit the bell for future videos.